All right, here's a question from the last exam where you needed to use decimals or a graphing calculator and use regression to determine a function that models that data. Okay, and a number of people had troubles with it, so I thought I'd show you an example. Okay, so what I need to do is I need to get all of this data into your graphing calculator or into decimals. So let's use decimals. So I'm going to hit plus here and add a table. So X1 January will be the first month, and the what is it there? Hours of daylight are 7 hours. In February, it's 8.6, 10.73, 4, 13.15, 5. Hopefully I'll get all these right. And that's one thing you need to do is just make sure you're checking as you go to make sure that all your numbers are accurate. Uh, 9.18 and 12 is 7.70. There we go. Okay, so I have all this data, and on my graph I can't really see them, but if I move over, it looks like now I can see them. And I can zoom in or I can change stuff in the graph. But it looks like that's like one period of a graph. And it makes sense for a yearly kind of hours of daylight to be a periodic type function. So now I want to determine a function that models that data. I might be able to answer, the question says, what's the amplitude, phase shift, period, and vertical translation? We'll get that when we model the function. But a couple things you could say is like the period, it looks like it takes a whole year or 12 months to repeat one revolution. You could also say the top mark is pretty close to 18, somewhere in there. They've got 17.48. The model might go just a touch above that. The lowest number seems to be about 7, and I can read that from the graph, or I can read that from the table there. But let's now model it with a function. Okay, so here's where I type in that thing that I had in the question. So y1, and put that tilde in, and then I have a sine bracket b bracket again, x1 minus c over b, and the two brackets, and put a plus d in there. There we go. So now you take a look, and that function that is graphed now, it looks like it's hitting all of those dots pretty well. So that's the pattern that models those dots. So now when I take a look at it here, I see what A is, B is, C, and D, and I can put those into my function, or in a functional notation. Let me write them down. So I would have y is equal to, so let me write all that stuff down again. A sine, and then b bracket x minus c over b plus d. So A, they say, is 5.07 sine bracket. B is 0.52, let's call it, bracket. X minus C is 1.87 over 0.52, that's C, plus, and D value is 12.26. 12.26. Okay, so this function then models that data. And I could ask questions about it. Like I do on question number 21, I could say, well, what is the value of y when I plug in a certain number for x? In this case, though, I'm just asking for the amplitude, phase shift, period, and vertical translation. So the absolute value of A, or the absolute value of 5.07, is 5.07, that's my amplitude. Okay, phase shift, to get the phase shift, that's C over B. So C is 1.87, B is 0.52. When I divide those two, I think I get 3.6 something. when you divide it. I forget what it is, but it'll be close to that. And also the phase shift has a direction, right? And so our phase shift here was a positive B and a positive C. And so I would say that here's my function, there's a minus there. Therefore, both of these are positive. So this thing is going to move to the right. It'll be shifted to the right. Okay, period. The function for period or formula is 2 pi over b. So it'd be 2 pi divided by b. B was 0.52. Okay, so figure out what that is. I think it's 12 point something or other. And then they want to know the vertical translation too. So the vertical translation is just equal to d. So it's going up by 12.26. All right, hopefully that helps you maneuver decimals as you're solving questions like that.